following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today, eventually we're going to go on and finish section 10.4 part 2. But before we do that, I have some things that I want to review with you. So let's get to that. All right. Yeah. There we go. All right, so the form of the second degree equations that we looked at yesterday looks like this. Y equals a times the quantity x minus h squared plus k. From that, we get the axis of symmetry, and it is at x equals h. Now, I mentioned this yesterday, but some of you still aren't getting it. When it asks for the axis of symmetry, it's an equation. You have to put in x equals whatever that h value is, not just the h value, as we'll look at here in a minute. Okay, and the vertex is at hk, and if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens downward. Okay, so let's take a look over here at the WebAssign problem, this specific one. F of x equals x minus 1, the quantity squared, plus 4. So h is 1, and k is 4. So the axis of symmetry is at x equals 1, not just 1, but x equals 1. Since a is not listed here, a is an implied 1, a positive 1, so the parabola opens upwards. So let's see how that checks out. All right, let's take a look at one more here. In this case, h would be -3. So we're going to have -3, and k is -4. So the axis of symmetry again is at x equals -3. Here, a is a -7, so the parabola opens downward. All right, now, a couple other things I want to talk about. Yesterday, I accidentally stopped the recording when I was trying to stop the share button. And so the video ended rather abruptly, but what some of you didn't pick up on was then I started a new video that was listed in YouTube right below it that lasts a couple of minutes. So it's all there, it's just two different videos. So if you missed that second part, go back and look at that second video. Another issue is that students are rounding off answers when they shouldn't. So let's say, for instance, you come up with an answer that's like 1 plus the square root of 17, okay? Leave it. Don't decimal approximate it unless it specifically asks you to, okay? So again, don't round off unless it asks you to, and if it does ask you to, be sure to round off to the correct number of places. Okay, let's see here. Those were the things I wanted to talk about from yesterday. So now what I want to do, I'm going to switch this screen. And give me just a minute. Okay, let's see here. Things are moving slowly. Okay. Righty. All right, good to go. Now, what I want to look at today is a different form of a second degree or quadratic equation, and that is the form y equals ax squared plus bx plus c. When an equation is in this form, the axis of symmetry is at x equals negative b over 2a. And the vertex is at negative b over 2a. Recall that the x value of the vertex is the same number as the number in the axis of symmetry, x equals whatever that number is, okay? And then we're going to plug that x value in to get f of that value. Now, this may seem rather complicated. It's not. We'll take a look at it. All right. So let's take a look at problem number 3 over on the left side of the screen from WebAssign. Okay. It says f of x equals x squared plus 4x plus 4. All right. It asks us to find the vertex and the axis of symmetry. I'm actually going to find the axis of symmetry first. So this equation is in the form y equals ax squared plus bx plus c. Okay, so a is 1, b is 4, and c is 4. So using the formula x equals negative b over 2a, we get negative 4 over 2 times 1, which is negative 4 over 2, or just negative 2. So from this, we get the axis of symmetry is x equals negative 2. So over here, we'll put in x equals negative 2. Again, not just negative 2, but x equals negative 2. All right. Now, I also know that the x value of the vertex is negative 2. How do we find the corresponding y value? Well, if you have an equation or a function and you know an input value, to find the output, just put the input in. Okay, so back over here, we're going to find f, oops, this thing keeps moving on me here, f of negative 2, which is going to be negative 2, the quantity squared, plus 4 times negative 2 plus 4. Negative 2, the quantity squared is 4, plus 4 times negative 2 would be minus 8, plus 4 is going to be 0. So the vertex is at negative 2, comma 0. So let's go over here and put in our 0. Okay, now this A is the same A that's in this form, okay, with the same ideas behind it. So in this case, since A is a positive 1, this thing opens upwards, okay? So let's see if that's correct information. And there you have it, okay? So we're finding the same things. A is the same. The way you write the axis of symmetry is the same. X equals whatever number, because it represents a vertical line. So x equals a constant would be the equation of a vertical line. But we find the vertex using x equals negative b over 2a to find the axis of symmetry value, plugging that in to find the corresponding y value. All right, let's do another one of those right here, number 4. Okay, so we have f of x equals negative x squared plus 6x minus 19. So A is negative 1, B is 6, and C is negative 19. I really don't need to write down what C is to find these two things. It's just kind of a habit. So let's see. The axis of symmetry is at x equals negative b over 2a. So that would be x equals -6 over 2 times -1, -6 over -2, which is 3. So the axis of symmetry is at x equals 3. So we're going to come over here and put in x equals 3. And we already know that 3 is the x value of the vertex. So now we're going to find, so let's see, we're going to say f of 3 is negative the quantity 3 squared plus 6 times 3 minus 19. Order of operations, we do the exponent first, so we get 9, but then it's negative plus 18 minus 19. And that is what? -10, I believe? Yeah. So the vertex is at 3, -10. So we'll come back over here and put in -10. Now, A was -1, so this thing opens downwards. And let's see what happens. And there we go. Okay, so we're finding the same things we found yesterday, the axis of symmetry, the vertex, and then we can plot this thing. But there's some other things I want to look at before we start graphing, and that is intercepts, x and y intercepts. How do you find an x-intercept? Whether you're graphing a linear equation or a quadratic equation or whatever other equation, to find an x-intercept, so to find an x-intercept, set y equal to 0. So basically you're going to complete that ordered pair. Okay. To find a y-intercept, what do? Set x equal to 0. Okay, so to find x-intercept, set y to 0. To find y-intercepts, set x equal to 0. Okay, let's go down here and let's take a look at this one, problem number 7 from WebAssign. It says find the x and y intercepts of the graph of the quadratic function. Okay, so we've got f of x equals x squared minus 2x minus 15. To find the x-intercepts, we set y equal to 0. Remember that f of x is the same thing as y. So if we set this equal to 0, y equal to 0, oh, this looks like the form that we use when we use the quadratic formula to solve the equation. That's right, it is. So let's see, we've got a is 1, b is -2, and c is -15. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 2 plus or minus the square root of 4 plus, you've got -4 times 1 is -4 times -15 would be a +60 all over 2. X equals 2 plus or minus the square root of 64. 4 plus 60 all over 2. X equals 2 plus or minus the square root of 64 is 8 all over 2. X equals 2 plus 8 over 2, which is 10 over 2, which is 5, and x equals 2 minus 8 over 2, which is -6 over 2, which is -3. So x equals 5 and -3. Those are the solutions to this quadratic or second degree equation, but we found that by setting y equal to 0. So these are x-intercepts, and written as ordered pairs, they would look like that. However, notice over here in WebAssign, it says to put the smaller x value first, which would be -3. So I'm going to have -3, comma, 0, and then 5, comma, 0. Now, in past quarters, students have not bothered to put the zeros in there, okay? When it's written in this form for intercepts, you must put the 0 in for the appropriate X or Y, okay? Not just the -3 and the 5. Okay, now to find a Y-intercept, we're going to set X equal to 0. So let's go back here to this. Oops. Let's try that again. There we go. So we've got what? Y equals x squared minus 2x minus 15. All right, if we set x equal to 0, so like f of 0 would be 0 squared minus 2 times 0 minus 15. It's just going to be the c value, the constant, because if x is 0, this term's going to be 0, this term's going to be 0. All that's left is the c value. So the y-intercept would be at 0, comma, negative 15. And there we have the x and y intercepts. All right, let's do another one of those. Let's see. Let's do this problem because it not only has us find the vertex, an x and a y-intercept, but also to graph it. So let's go through the whole thing. Okay. So we have f of x equals x squared plus 4x plus 4. A is 1, B is 4, and C is 4. To find the vertex, we need to find what? The axis of symmetry is at x equals negative b over 2a, which is negative 4 over 2 times 1, which is negative 2. So at x equals negative 2. Now, they don't specifically ask for it in this problem, but the x value here is also the x value of the vertex. So then I'm going to find f of negative 2, which is negative 2 the quantity squared, plus 4 times negative 2, plus 4, which is 4 minus 8, plus 4, which is 0. So the vertex is at negative 2, 0. Okay? So negative 2, comma, 0. X-intercepts. To find x-intercepts, set y equal to 0. Well, if y equals 0, we'd have 0 equals x squared plus 4x plus 4. I already found a, b, and c. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 4 plus or minus the square root of 16 minus 16 over 2. X equals negative 4 plus or minus the square root of 0 over 2. X equals negative 4 plus or minus 0 over 2. X equals negative 4 over 2 or negative 2. So the x-intercept, we set y equal to 0. So x-intercept is at negative 2, comma, 0. So in this case, it looks like the vertex is also the x-intercept. Negative 2, comma, 0. Notice we only got one x-intercept too, all right? The y-intercept, to find the y-intercept, what do? You set x equal to 0. So what's y going to be? Well, if x is 0, that's 0, that's 0, and so 4 is going to be your final value there. Okay, so remember f of, let's see here, 0 would be 0 squared plus 4 times 0 plus 4, which is just 4. Okay, now to graph this thing, just like before, graphing parabolas, first of all, we want to turn this square blue. We want to start with the vertex, negative 2, 0, and then plot one other point. Well, I already have a couple more points here that I found, so I don't have to find any new points. Let's see. The x-intercept is at -2, 0. Well, that's the same point here, so I can't use that. The y-intercept is at 0, 4. And there we have it. Let's see what it says. Okay, so we find the axis of symmetry using x equals -b/2a. We take that x value. If we're writing the axis of symmetry, it's an equation, x equals that number. If we're finding the vertex, this is the x value of the vertex. We plug that in to the function to get the corresponding y value. To find x-intercepts, set y equal to 0. To find y-intercepts, set x equal to 0. When you list the intercepts, list them as ordered pairs. To graph the function, the parabola, plot the vertex first, and then a second point. Okay, let's see here. How are we doing for time? Let's do one more of these. Let's do this one, okay, because it has 2 x-intercepts. All right. So we have f of x equals x squared plus 2x. So in this case, a is 1, b is 2, and c is 0, right? Because there's no constant term out here, but it's as if though it was like plus 0. Okay. So I'm going to use, let's see, x equals -b/2a to find the axis of symmetry. And that's going to be x equals -2/2 times 1, -2/2, -1. So the axis of symmetry is at x equals -1. Now, again, this particular problem didn't ask us to find it, but I just want to go through it for the practice, and we need to find that x value anyway. So now, f of -1 is going to be -1, the quantity squared, plus 2 times -1, which is 1 minus 2, or -1. So the vertex is at -1, comma, -1. Okay. Moving on. To find x-intercepts, set y equal to 0. If we set y equal to 0, we get this. Using the quadratic formula, we've already found a, b, and c. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Whoops, all over 2a. X equals -2 plus or minus the square root of 4 minus 0 all over 2. X equals -2 plus or minus the square root of 4, because 4 minus 0 is still 4, all over 2. X equals -2 plus or minus the square root of 4 is 2, all over 2. So we get -2 plus 2 over 2, which is 0 over 2, which is 0, and -2 minus 2 over 2, which is -4 over 2, or -2. So x equals 0, x equals -2. So those are the x values of the x-intercepts. So 0, 0, and -2, 0 would be the x-intercepts. Okay, so, oh, and it says the smaller one first, so we use the -2, comma, 0, and then 0, comma, 0. Okay. The y-intercept is, to find the y-intercept, we find f of 0, which is 0 squared plus 2 times 0, which is 0. Or we just look at the constant right here is 0. So the y-intercept is also at 0, 0, the origin. Okay, now we're going to graph this thing. The vertex is at -1, -1. Always look at the scale on these graphs because sometimes they change the scale. So -1, -1 is right there. And then we can use any of these points, just one point. How about the origin? And there we go. All right, let's see what it says. Okay, excellent. All right, now we're going to look at some story problems. And what I'm going to do, I'm going to pause the recording for a minute. All right, we'll start at the recording again here. And now we're just going to look at the whiteboard and look at some application or story problems. These have to do with triangles and rectangles and finding areas and lengths and distances and everything. All right, let's see. Actually, I lied. That's the other class's stuff. We're still going to be looking at things involving second-degree equations, okay? This says operating costs. The cost C in dollars of operating a certain concrete cutting machine is related to the number of minutes in the machine is run by the function C of n equals 2.2n squared minus 66n plus 655. For what number of minutes is the cost of running the machine a minimum? Excuse me. What is the minimum cost? All right, let me read the problem to you again. It says the cost C in dollars, so that's the dollars, of operating a certain concrete cutting machine is related to the number of minutes in. So our input is the number of minutes, the output is the cost, according to this function. For what number of minutes, so that would be in, is the cost of running the machine a minimum? And what is the minimum cost? All right, let's talk again about parabolas for a minute. If we have a parabola that opens upwards, the vertex is the minimum. If we have a parabola that opens downwards, the vertex is the maximum. So in fact, for the parabola that opens up, the x value would represent the axis of symmetry. The y value would be the minimum output value. For a parabola that opens downward, the x value would be the axis of symmetry, and the y value would be the maximum y value. Okay, so here, if we look at this second degree equation, we see that A is 2.2, which means that this parabola, the graph of it, is going to open upwards, which means, since it opens upwards, it's going to have a minimum y value, or in this case, C. So if we want to determine for what number of minutes the cost of running the machine is a minimum, and then what is the minimum cost, we want to find the input followed by the output of the vertex of this graph, if we were to graph this parabola. Okay, so what have we got? A is 2.2, B is -66, and C is 655. Okay, so to find the vertex, we're going to use x equals -b over 2a. Now, technically, we're using the input as in, but I'm going to just use x and y to start with. So negative times -66 over 2 times 2.2, which is positive 66 over 4.4. 2 times 2.2 is 4.4. So now 66 divided by 4.4 is 15. Okay, so that's the input of the vertex. That's the number of minutes that produce the minimum cost. Okay, now C of 15 would be 2.2 times 15 squared minus 66 times 15 plus 655. And let's see here. 15 times 15 is what? 225. And 66 times 15 is 990. And then what? 225 times 2.2. So we've got 495 minus 990 plus 655. So 495 minus 990 plus 655. And I'm getting 160. So, and that's money. So the number of minutes is 15. So 15 minutes. And the minimum cost is $160. All right. If we were graphing this thing, that ordered pair would be the vertex. And since this is has an A value that's positive, the graph would open up. And so this vertex would be at 15, 160. But again, it asked for what the number of minutes, which is the 15, and then the minimum cost, which is the $160. Be careful. A common mistake is that students find the two pieces of information, but they don't read the questions really carefully. And so sometimes they get them backwards. Okay. All right, hang on just a minute here. I just wanted to make sure I was still recording. Here is a new scenario. It says, fireworks. A fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height s in feet after t seconds is approximated by the equation s equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, first of all, let's rewrite our quadratic equation in descending powers or standard form. We see that A is -16, so the parabola, the graph of it, would open downwards. The vertex would be the maximum. Okay, now let's see. T is time in seconds, and S is the height above the ground. So our ordered pair of the vertex is going to be the time at which it reaches the maximum height and the maximum height. So again, we're looking for the vertex. Okay, A is -16, B is 120, and C is 0 in this case. Okay, so X equals -B over 2A would be -120 over 2 times -16, which is -120 over -32. And let's see, if we take negative divided by negative is positive, 120 divided by 32 is 3.75. So that's time, so that's seconds. So that's the time it takes to reach the maximum height, okay? Then to find that maximum height, we're gonna put 3.75 in for t. So S equals 120 times 3. Wait, let's use this one here. Okay, hang on. It really wouldn't matter, but I want to be consistent. S equals -16 times 3.75 squared plus 120 times 3.75. And going to the calculator, -16 times 3.75 squared plus 120 times 3.75, and I get 225. And that would be what? Feet. So the first question said, how long after being fired? 3.75 seconds. And at what height? 225 feet above the ground. notice in both of these examples, we're finding the vertex. When it's a parabola or a second degree or quadratic equation, it's asking you to find a maximum or a minimum. It's going to involve the vertex. Okay, let's see here. This says projectiles. A ball is thrown straight upward from the top of a building, okay? With an initial velocity of 32 feet per second. The equation S equals negative 16t squared plus 32t plus 48 gives the height S of the ball in feet t seconds after it's thrown. So t is time in seconds after the ball is thrown, and S is the height of the ball. So very much like the last problem, okay? Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. Okay. So let's see here. There's the ground. We want to have nice brown ground. Okay. So just looking at the picture, we can see that it's a parabola opening downward. And notice A is negative, which means that the graph would be a parabola opening downwards. Okay. So right here at the vertex, that would give us the time that it reached the maximum height. The Y value or the S value would be that maximum height. Okay, but let's see, it says find the maximum height reached by the ball. Okay, so it doesn't ask us for the time, but we'll still need to find that in the process. So we're looking for the vertex. Okay, so A is negative 16 and B is 32, C is 48, X equals negative B over 2A, negative 32 over 2 times negative 16, negative 32 over negative 32 is 1. Okay, so it takes 1 second for the ball from the time it's thrown to reach the maximum height. We need that because now that maximum height is going to be when t is 1. So this is what, negative 16 plus 32 plus 48, which is 64 feet. So the vertex is at 1, 64. The maximum height is 64 feet, okay? It said, where did it go here? Find the maximum height reached by the ball. Then it says, and the time it takes for the ball to hit the ground. So this is different from the last problem. They want to know the time right here. Well, what is the height of the ball when it hits the ground? 0. So if the height is 0, we have this. Solve for t and we'll know the time. So basically we're looking for the x-intercepts, or in this case, the t-intercepts of the graph. Okay. So what have we got here? We've got these A, B, and C values. So t equals negative b plus or minus the square root of b squared minus 4ac. You know what I'm going to do? I'm going to rewrite that on the next page where I have lots of room. So let's see. We're going to have 0 equals negative 16t squared plus 32t plus 48. And we said that A is negative 16, B is 32, and C is 48. Okay, so T equals negative B plus or minus the square root of B squared minus 4AC all over 2A. T equals negative 32 plus or minus the square root of, let's see, 32 squared is 1024 minus 4 times minus 16 times 48 is going to be a plus, and 4 times 16 times 48 is 3072, and that's all over 2. I said 2a, but it should be over 2a over negative 32. Okay, so t equals negative 32 plus or minus the square root of, let's see here, that plus 1024, 4096 over negative 32. And let's see here, to the 0.5. T equals negative 32 plus or minus 64 over negative 32. The square root of 4096 is 64. Okay, so t equals negative 32 plus 64 over negative 32, which is 32 over negative 32, which is negative 1. T equals negative 32 minus 64 over negative 32, which is negative 96 over negative 32, which is 3. So t equals negative 1 and t equals 3. So graphically, those would be the t-intercepts, okay? So it's like, this would be what, negative 1, 0, and this would be 3, 0. Well, the problem started up here, and t can't be negative, time can't be negative. So what's the correct answer? 3 seconds. So this value right here. So what's the maximum height? 64 feet. When did it hit the ground? 3 seconds after it was launched. Okay. All right, I want to take a look at another application problem. It says police patrol officer. Suppose you are a police patrol officer and you have a 300-foot long roll of yellow do not cross barricade tape to seal off an automobile accident, as shown in the illustration. Okay, what you can't see in the illustration is that it's a rectangular shape. Okay, so we've got this rectangle. It says, what dimension should you use to seal off the maximum rectangular area around the collision, and what is the maximum area? All right, so here's what we know. We have 300 feet of tape, all right? And we're forming a rectangle. We want to get the dimensions of the rectangle that would produce the maximum area inside the rectangle, and we want to find that maximum area. Okay, if the whole thing, if this distance all the way around it is 300 feet, then half of it, so in other words, these two sides would have to equal 150. Okay, half of 300. Now, let's say we've got two sides of a rectangle and it equals a total of 150 feet. Okay, so this whole thing is 150 feet. If let's say I call this piece X, if the whole thing's 150 and this is X, this would be 150 minus X. So if this is X, this is 150 minus X. Again, we had a rectangle, the whole thing was 300 feet around it, so half of it is 150. If we take X away, we have 150 minus X for that remaining distance. Okay, now, area of a rectangle is length times width. So the area would be 150 minus X times X. The area would be 150X minus X squared. I'm going to write it as a function and say A of X equals negative X squared plus 150X. Okay, so there's the equation of which X would be this distance and A of X would be the area. Now, we want the dimensions, so we need to figure out what X is, and we want the maximum area, so we need to find out what A of whatever that X value is. Notice this is a parabola opening down. So the vertex would give the x value that produces the maximum area and the y value, which is the maximum area. Okay, so A is -1, B is 150. X equals negative B over 2A, negative 150 over 2 times -1, negative 150 over -2 is 75. So X is 75. 150 minus X is 75. So the dimensions are 75 feet by 75 feet. The maximum area, we could find it by taking 75 times 75 or finding A of 75. Let's find A of 75. So A of X equals negative X squared plus 150X. A of 75 equals negative 75 squared plus 150 times 75. And let's see, we get negative 75. Oops, got to turn the calculator on. 75 squared plus 150 times 75. And we get 5625, which, like I said, is also the same thing as taking 75 times 75. Okay, so that's, so the maximum area is 5625, and that would be square feet. All right, we're out of time, pretty much. I'll be back at 1:15 with an office hour if you have any questions. There's one more thing I want to look at. Hang on, because I think, if I'm correct, that this is the last section we're covering in this chapter. So, yep, that's what I thought. Okay, so tonight's homework is to finish up section 10.4 and the chapter review. Tomorrow we'll be reviewing for a test on Thursday. All righty, that's it for today, folks.